Hello, bachas. Welcome back to the channel, the F in Physics, where the F in Physics stands for fun. So, in the previous video, we saw about potential dividers. Okay, we said potential dividers can have fixed output or variable output. We saw the working of potential dividers with fixed output, and this is the formula. We are going to use the same logic with potential dividers with varying output. Okay, so let's talk about potential dividers with varying output. The first, what you need to know is whenever the output is varying, you are going to use a variable resistor. What are the variable resistors you can have? You can either have a variable resistor that you are going to vary manually, okay, or you can have variable resistors that depend upon the environment. Say for example a thermistor. Okay, unlike normal resistors where temperature and resistance are directly proportional, in thermistors, as your temperature increases, your resistance decreases. Okay, which means if your resistance is decreasing, the voltage across the thermistor has to decrease. Or you can have a resistor that depends upon light, which is your LDR. Over here, as your light increases, your resistance will decrease, so the voltage across it will also decrease. Okay, so if I have to use them in any of my potential divider circuit, let's take the same circuit which we had before. This is 9 volt. This is a bulb, I believe, working at 3 volts. Yeah, 3 ohm. 3 ohm. And here is my thermistor or LDR, you can take anything, or a variable resistor. Let's assume at room temperature, its resistance is 6 ohm, and at a temperature, let's assume 90 degree, its resistance is 1 ohm. Okay, because as temperature increases, your resistance has to decrease. Now you see, as my temperature over here varies, its resistance is going to vary, and therefore its voltage across it is going to vary, which means the brightness over here will vary. How will the brightness vary? See, my brightness is dependent on, it depends on the voltage across the bulb. If your voltage across the bulb is increasing, its brightness will increase. This brightness does not depend upon current, it depends upon voltage, because brightness is basically light energy and voltage is related to energy. You're understanding this? Okay, which means for the bulb to be more bright, its voltage has to be more, which means voltage across the resistor has to be less. This is what you need to know. So my output over here is varying, the brightness is varying depending upon the resistance of the resistor. Okay, and you can find out the voltage at room temperature or at 90 degree using the same formula. R1 upon R2 is V1 upon V2, and you have to use V1 is I times R1 and so on, the one that we used in the previous video. What will they ask you in MCQs? They will give you a similar circuit but now arranged vertically. Okay, so you will have 1, you will have 2, of which one will be a variable resistor. Let's assume in this case it's an LDR. Okay, and let's assume here is my output voltage. What you need to know, see, my voltage output, okay, is nothing but, let's assume, voltage across resistor 1. Okay, and I also know V1 plus V2 is your total voltage, which means if my V1 has to be large, my V2 needs to be small, and vice versa. Okay, which means this output voltage depends upon how much voltage is consumed by the LDR or any other resistor in series. It could be a thermistor as well. Normally they ask this in MCQ. Okay, so if light is more, the resistance across resistor 2 is going to be less, and therefore voltage across this resistor is less. And if your V2 is less, V1 is more, which means your output is large. In another scenario, when light is less, resistance of the second resistor is going to be larger, which means voltage across this component is going to be larger. So now if your V2 is more, V1 will be compromised. And if V1 is compromised, the output voltage, because it is connected across 1, will be compromised. So your output voltage has to be less. Are you all getting this? Okay, so you will have to play with first these relations, and second where they are connected, and where the output voltage is needed. Okay, so that part becomes very important. Now another part where kids face a problem is where you have a fixed resistor, okay, connected to a power supply. So let's assume this is 10 volt. Okay, just marking 2 points on this, point A, point B. What I am going to do is I am going to take another wire, okay, which is connected to the voltmeter, and this pointer I am going to slide from A to B first, and then slide from B to A, and I am going to see what happens to the voltmeter readings. Okay, what you need to know is this voltmeter is measuring the voltage between the fixed end and the moving end. So whenever they give you such questions, you have to find your fixed end and your moving end. Okay, for this question, my fixed end, how do you determine the fixed end and the moving end? See, this is the wire that you're taking. This arrow becomes the moving end, which means the other end becomes the fixed end. Okay, once you have identified your fixed end is near A. Okay, remember now, for this resistor, as length of the resistor increases, its resistance is going to increase, and if resistance is increasing, you will be measuring a larger share of voltage, which means as you go from A to B, you are going away from the fixed end, which means the length of the resistor is increasing, across which you are measuring the voltage, of course. So its resistance will increase, and therefore the output voltage that will be seen over here will increase. Okay, if you're coming from B to A, you are coming towards the fixed end, and if you're coming towards the fixed end, the length that you're measuring across the resistor is decreasing, therefore its resistance will decrease and the output voltage will decrease. Okay, so this is how your voltage will vary based on where the moving end is. Another way to understand this, see, I know for the total length AB, my voltage across AB has to be the voltage across the supply. It has to be voltage of the supply, which is 10 volt, which means if I am halfway at the length of AB, my voltage across the length will be half of 10, which is 5 volt. Okay, so if I'm measuring the total length from A to B, I'm measuring basically 10 volts, but if I'm measuring half the length, you see I'm coming towards A, I'm measuring only half the voltage. Okay, which again tells us that if you are moving towards the fixed end, your output voltage will decrease, whilst if you're moving away from the fixed end, your output voltage is going to increase. Okay, so this was a quick video on potential dividers. Do hit the like button, subscribe, share. Adios.